Good afternoon. I welcome the team to this webinar. Probably this is the extended version of the webinar which I did last month, where I introduced about MDK v6 toolset and its features. What are the additional features we have in specific, in addition to MDK v5 toolset, what the attendees are aware of. So I believe attendees are familiar with MDK. The MDK stands for Microcontroller Development Kit, which has been popular in the market, which is there in the field for more than probably 2 decades now. And recently ARM has come with the latest version of MDK, which is v6. And last month was just a brief introduction, a kind of overview on the MDK v6 and to tell about what are the features included in that. And today will be a technical demonstration, a deep dive into MDK v6. And next month I'll be coming with the next version or advanced version of MDK v6 in the month of October. So as per the agenda, we will go. So before starting with today's session, I would like to just talk about a few slides what I spoke for last September. Hope the team is able to see my screen. Right. So this was the thing which we discussed in specific in the last month webinar, MDK version 6. So MDK version 6 means please don't be under the impression that ARM has come up with another MicroVision 6 IDE. No, ARM continues to update or work towards getting MicroVision 5 only. But MDK v6 ARM brought specifically for the customers who wants to use the license on the platform other than Windows. Many customers were not able to use Keil toolset on other OS platforms because it was restricted to be working only for Microsoft Windows OS. That was the reason MDK version 6 was brought into existence. So as you all are aware, MDK MicroVision still continue to work on Windows. Then what is that ARM has come up in getting this MDK version 6? That is nothing but the Keil Studio. So this webinar will be specifically talking about Keil Studio, desktop version of Keil Studio. So what they did is they have given the pack extension for Visual Source Code, VSC we call it as. So Microsoft Visual Source Code, everyone knows it's a very popular platform and it works across all the OS. So taking that as a base, as an IDE or a platform or a GUI, ARM has given the extension for Keil Studio pack. So this is what we will be seeing in this webinar. And apart from that, we also have ARM debugger. ARM debugger is this very popular debugger. Please don't confuse this ARM debugger with the one what you get with MDK. MDK, though you get the debugger inbuilt in the IDE, but the debugger was supporting only the devices which are supported in Keil MDK toolset. But this ARM debugger is a traditional debugger which ARM developed as part of ARM RVDS Real View Developer Suite, or you can take it as Real View Eyes, which was way back old. The same debugger support is implemented here, so that indicates you can still use this same debugger which is supporting for Cortex and all. You can still use that same debugger in MDK v6 as well. One more feature of this is we have CMSIS toolbox. So CMSIS is, as everyone knows, Cortex microcontroller software interface standard, and this is a standard which was brought in joint collaboration with ARM, silicon vendor, and development tool vendors. So this toolbox will give you the files on how to run the CMSIS pack or CMSIS based project from the command line option. And we also have Artifactory. I'll tell you what is those Artifactory. And You also have file middleware. So ARM continues to give their middleware stack for file system, USB host, device, network, TCP/IP version 4 and version 6. But until MDK v5 evolve were given in the form of object format only. If a customer wants to modify any of the API of this middleware, it was not possible because ARM is to give those in the form of library format. But from MDK version 6 onwards, even the source code of those middleware stacks is made available through GitHub. GitHub, as you everyone know, it's open for download, but even if you download this middleware project, you'll not be able to build the project until you have the MDK professional license. One more highlight of this MDK v6 is it is FUSA RTS, which is Functional Safety Real-Time System. So earlier this was an add-on option or add-on purchase for MDK Professional. Now this is given as part of MDK. And in version 6, it is FUSA is also extended to M23, M33, M55 and other Cortex processors. FUSA doesn't work for Cortex-M. So this was the Artifactory which I was talking about. Earlier, any customer want to download any software or anything pack, they used to go to Keil.com. We still continue to be. Like from the Keil, if you download MDK ARM software demo version, is available on the Keil site. You'll be getting MicroVision Editor, MicroVision Debugger, Pack Manager, Project Manager, ARM Virtual Hardware, Fixed Virtual Platforms, and the ARM Compiler. Okay, but not only with the Keil, now we can also use other options, other way, from various ways we can still get these packs or download the executables. But now we were talking about MDK v6 where Keil Studio Pack was given as an extension for VS Code. So to download that VS Code extension, one has to go to VS Code Marketplace. So VS Code extension has ARM Debugger, it has Device Manager and Project Manager. So this is the Artifactory, CMSIS Toolbox, ARM Debugger, your ARM same FVPs, ARM Compiler, LLM, GCC. So it's the same thing. So this was just 2 slides. I just wanted to quickly review what we covered, and because this session is the extension of that specific webinar. So now let's launch VHDL source code. So this is my visual source code. Okay. So this you can download from visual source code from the internet. And here, any extensions. Suppose here you want to download the Keil Studio Pack. You can directly give Studio Pack. Keil Studio Pack. So this. So if you are not able to find where the pack is, it's available on ARM site. You get the hyperlinks, but you can also find out this extension from the Visual Studio itself. So first you install Visual Studio, Windows version or whatever the OS you're working on. Then if you go to extensions and type Keil Studio Pack, you can select this and it's already installed for me. Okay, this has 6 dependencies. So what all it has? It has CMC solution, it has ARM Device Manager, ARM Debugger, ARM Environment Manager, ARM Virtual Hardware, and CLAN-D. This is your ARM Compiler 6 LLVM. One thing to note here is to work with the project which was earlier developed in MDK and you want to use that project in this v6, it's possible. You can migrate your projects which are developed in MDK v5 to MDK v6 because MicroVision is very famous and popular in the field and many customers are using it. So we will be starting with converting the microvision project to C solution project. C solution means this is the VS Code project. Okay, so after doing this, as soon as you install, the license will be usually activated. Community edition license, which is this non-commercial free license, is available on Keil site or ARM site. You can easily, it will activate by itself for 30 days. Because I have the professional license with me, so I'm using this license. So it shows here MDK professional license. Okay, so let's now go to CMSys. So we can give it as a new solution. When you're creating a new solution from scratch, or you can convert your microvision project to C solution. To convert the microvision project to C solution, one thing mandatory here is the project what you're importing from Keil has to be built with compiler 6 compulsorily. If you have developed the project with microvision 5 IDE, it supports both compiler 5 and 6. If at all the project is developed with compiler 5, you'll not be able to migrate that project successfully to C solution. Okay, for that, there is one more step involved: converting or migrating your projects from compiler 5 to compiler 6. And then we can convert your project developed with compiler 6 to C solution. Okay, so I have already one with me, which I have already done. So as soon as I convert the project, we have to observe for 3 specific files. One is VC package, C project YAML file, C solution ML file. Okay, so now these files will be automatically created once the project is being transferred to MDK version 6, or we tell it as C solution project. So what does this VC package do? This VC package specifically tells you what are the required components or packages this particular project requires to be built successfully, or these packages are required to further develop on this project. Okay, so this requires CMake, because it's a make utility. You have ARM CLang 619 and the CMSys toolbox version. So suppose I'm using the latest version of software, or some customer is using old version of software. So I want to build this project using that. So how will I do that? I can go here and I can select. Now I'll select here CMSys toolbox latest version, ARM compiler version latest 6.22, like that, whatever the required. As soon as I do the changes, it gets reflected here. And now you can save this. It gets saved. Okay. For some customers, they require older version of CMSys or older version of ARM compiler 6. See, for this, that time you have to modify this as per the required compiler version you want. So it's because I selected here 6.2, it's showing this much only. Otherwise, it can go up to even 6.19. Okay. After that, we have to look into C solution ML. What is this C solution YML? If anyone has a question, I can also correlate this with MDK v5 so that you can easily understand what is this YML file. All this, what you see in this file, these are all showed in the form of a Windows there, a dialog box, or a Windows dialog in the Keil MDK v5. If anyone is interested, I thought I'll compare these two for better understanding, then I thought, okay, it will be too much. Sometimes it does give a clarity, but sometimes if you don't follow, it will be again confusing. So what does this C solution YAML do? This specifically tells this particular project, Blinky project, is being configured for 3 different targets. One is for debug, one is for release, another is debug RAM. And this project is using the NXP LPC device, and the compiler I'm using is compiler 6, CMSIS toolbox version, and this whatever the converter from microvision to C solution. So Blinky, always C solution will give you what are all that particular project has been configured for which different targets. Then you have a project by ML which will tell you for each target. Suppose if I select debug, what is the required configuration, tool configuration. So here it tells me in detail. There it just showed what does the device. Now it will tell you for this particular device, what is the device family pack you have to use, what all packs are being used for this particular debug target. It shows Keil BSP, ARM compiler, we use MDK middleware there. This board is for specifically for some NXP board. This also uses the Ermin graphics middleware of Keil. Then it shows all the compiler options, linker options, assembler options. Okay, like this it shows, and it also shows linker. In the linker, we have to tell the scatter loader file through which linker will locate your code and data accordingly. So that also we have to tell. So the complete setup of the project Blinky for the target debug can be seen here. Okay, so this project YAML file is separate and individual for each of the target, which goes as part of your Blinky project. Right. So now if you go to CMSIS view, in CMSIS view, you can see in the folder format, like you see in the Keil MacroVision file. So you can see Blinky, this is a debug and all the files. Okay. So okay. Now coming to like how you have in MDK v5, we had a called of configuration wizard where ARM used to come up in the form of configuration with us with the help of this HTML tags in between. Okay, so now I suppose I want to change memory size, say 4 kilobytes I want to reduce. I can directly do it here, or I can go this way. And here you can see. So if you have worked on any RTOS application in Keil MDK v5, this is what similarly it shows. So how this configuration wizard is come with the help of this HTML tags, which maintains in their startup code and header file specifically, and not for scatter file, but very rarely. So here directly I can change whatever the changes I want. System configuration, I can directly change the memory here. Just an example. So you can do whatever changes here and it will get reflected in your header file here. So this project is basically a Blinky project. I don't have this board, but I use this as just as example project to show you the C solution feature. Okay. So now after this, we also have something called as here manage solution settings. This is you're building this project or developing project for debug mode, release mode, or debug target, release target, or debug RAM target you can do. And you have here open C solution on this. You have software components. This is nothing but your runtime environment. In the MDK v5, as soon as you create a new project, this real-time environment opens. So here you can select, this is for this particular project. Here you have a validation, similar you had in for MDK v5. So suppose if I remove any dependencies, it just shows me the error. So total, if I select all packs, there are 1,707 packs are given as part of runtime environment. Okay. So now specific for the Blinky only. So what all it uses the pack, board support pack for this board. We have CMSS. If you click here 6, you can see core is selected, DSP is selected because it's RTOS application. RTOS 2 is selected. Then CMSS driver, you see 27 drivers are there, but not all are used. Only I2C is used in this. And in the device also you have file system, you have USB. Like that, wherever you see the numbers, they are all dependent device packs are there. Okay. So now we will build the project. There is a hammer here, build. So it will start building my project, and if any errors or whatever is there, it will show it here. Okay. So after this, if you have the board connected, it shows under this device manager. Then if it is not, then we can select the device and add it, and then you can do the debugging, like how we have here the bug symbol. This helps you for debugging your code. Since I don't have the board, probably by next month I'll try to bring some practical demonstration where I'll download the code to the board and show you. But the debugger is not that advanced like the MicroVision, because MicroVision was developed in the span of 2 decades, the IDE. So it takes time to bring all those features to C solution for VS Code. So few features are implemented like single stepping, putting breakpoint, all those are there, but it doesn't still support all those trace features and all. But still, if you want to invoke the debugger from VS Code, you can invoke the debugger from here, and you can launch the Keil IDE from here only, and you can debug using the MicroVision debugger of, that is Keil MicroVision 5. That is possible. Okay. And yeah, so next part was in our program, in our webinar today, was cloning the Git repository project. So on the GitHub, lot of examples have been uploaded by ARM team. So for that, we can go to Explorer view. Sorry, help, welcome. Let me close all this. Okay, I'll open. Okay, first I'll show you the Git repository. So this is the GitHub. In the GitHub, if you type ARM examples, in that you'll get this hello world. Hello example, which will print hello world for 9 times based on the counter. This specifically is developed for ARM microcontroller prototyping board in PS3, which is Corstone 300. And FAP means this program can be run on the virtual platform, on the fixed virtual platform, and you need not connect hardware, and you can see the output, how it executes. Excuse me. Here you copy this link and then go to here and clone Git repository and type Control V. Then it will ask me where you want to create the project or download the project. So I have already created one in PS and select this folder, and it tells me to open. So now it is downloaded. It just takes few seconds. Okay, because this I've already run today morning to test everything is working fine. So this is quick fast. Otherwise, it will take few seconds or 1 or 2 minutes for all the associated and dependent packages to be downloaded from the CMSs. So this is the same MPS3 board. So we have here same VC package. This again, this project again requires this CMSS toolbox, ARM compiler. This is for 6.20 version because we're using fixed virtual platform here model. So this is that version of that FEP. If required, you can change the any version you want. Okay. And this also has your C solution ML and project YML. Okay, so now if you go to CMSS, select this and build. It's built now. Now it's time to, in the device manager, because it's a fixed virtual platform, here I can select Cornerstone. I have to select Cornerstone because this project for MPS3 is built on Cornerstone SSC 300. So once I select here and go to CMSS and run, so it connects to the virtual hardware and it prints 9 times hello world. That's it. So this is a simple project, hello world, which prints 9 times hello world, and to just show that the virtual platform is working fine. Okay. So now coming to creating a new solution. Okay. So you can go to new solution here. Let me close this. You can select the board, whatever the board if you are working for. So let's select this MPS. Let's select this MPS3 only. Just whatever we did now. Okay. Select. It's selected. So any template you want, any reference example, like you want blank solution, your trust zone, or CMSys, or any hello world specific to this board, you can select blank solution or the blinky example. So whatever you want, you can select, and then this is the name for the project where it will be created. So create. Okay, now you can see it's created. So this requires again compiler packages, so whatever required. So now you can go to CMSS and suppose I need to close the CMSS link only showing still. I can add any component I want, like you had in the source code templates and project templates, how you had in DFI, say for RTOS or anything. I'll show you. So select API like this, and you can select add from code component templates or probably RTOS. Add new file, add existing file, like how you had there in source group. You can add the file, you can add the existing file, or you can directly add it from the CMSS pack. Okay, and any pack information you want, like CMSS solution related information, so you can see the documentation directly. You need not go and search in Google. Just click on this link and it will take you to that particular backend extension on ARM side. Okay, you want to know what are the features included, custom editor commands. You want to know what are the commands. So you can see these are all the commands which you see in the YAML file. That is the C solution YAML file and project YAML file. So if you want to modify any of those files, you have to go through these commands. Change log. Change log is specifically because every time ARM is updating this pack, so any changes, modifications, features added, you can see the revision history here. So everything is available at the fingertips. So similarly, any pack information you can see. Okay. So yeah. So this is about migrating the project from microvision to C solution, and cloning the Git repository, and running the code on the FVP, and creating a new project. Okay. So now if there is any questions, I'll come to the questions. So if there is any questions, you can ask me. Yeah, hello everyone. I would really encourage the team, because MDK V6 comes with a lot of features, and customers are working on safety critical applications. I would really sincerely request them to go with MDK V6. You can download the community edition for 30 days actually, from the ARM side, which is specifically for non-commercial use. For commercial, you have to buy the MDK V6 license. So having said that, please don't set your mind saying that MDK V6 means, oh, okay, I have to learn VSC code. No, that is not the case. VSC code is based on only your requirement. If you have the requirement of running Keil on other OS other than Windows, then please go with. Otherwise, even your microvision 5 MDK does support MDK V6 features, which I've already demonstrated last webinar, where I built the sample project based on functional safety as well. So, how to select debugger from VS Code. Debugger, Janardhan, it gets automatically detected. Okay, because I don't have hardware, I would have shown you otherwise. It will get automatically detected. If the board has onboard debugger, it detects. Sometimes the board has onboard ST-Link, onboard J-Link. It detects. Even if you connect the U-Link or debuggers, ARM U-Link debuggers also, it detects automatically. Since I don't have the hardware, so I'm not able to show you that, but I'll ensure I'll try my best to get you the practical demo next month for sure, where I'll try to get some sample board working with the visual source code, and that time maybe you can have more clarity for that. So please excuse me, because for this webinar I don't have any boards, because these evaluation boards are from NXP, and we give only the evaluation boards from ARM. So, but we do have some boards from ARM. I'll try to get some sample project up and running by next month. Any other questions? Yes. It will be through ARM debugger settings. So when I connect a hardware, probably I'll be able to explain you more on that. Okay. Any other questions? So please feel free to send me email to geeta@gsasmspl, or you can send me, you can call on my number as well. I'll put it here. This is my email ID and phone 93437. Okay. So please, the team who has joined me, please download MDK v6 and have a feel of it with MDK Community Edition. And v6 also supports the legacy devices like 8051, 166, 251, like that. Yeah. So if there are any questions? Oh. So we'll end the session. Thank you. Thanks for your time.